Simplify and state the non-permissible value as restrictions on the variable. So we have a product of rational expressions. We could go ahead and expand these numerators, this one here and this one here, but we can also simplify our life a little bit by trying to reduce this, and in this case we can actually reduce it. This x minus 6 cancels against this x minus 6 right away, right? This x cancels this x, and then we can divide 3 by 3, leaving us 1. 6 divided by 3 is 2. And then we have a 4 up here still, so we can divide a 2 by 2 to get 1, and the 4 divided by 2 leaves us with 2. So what do we have left now? In the numerator we have a 2 times 2x minus 3. And in the denominator there's actually nothing left. There's a 1. We can put that 1 in if we want like that, but really it was eliminated. So actually I'm going to do that. So yeah, actually there's no point in putting the denominator, so I'm just going to write it like this. So we're done at that point. Now this is no longer a quotient, but we started with a quotient, which means anytime you have a rational expression, meaning you have an expression where you have a quotient and the variable in the denominator, there will be non-permissible values. So we need to state them. So here x cannot equal to 0 here. 6 times 0 is 0, and x cannot equal to positive 6. Okay, in B, we're going to do, we're going to see if we can reduce anything, but at this point we cannot. Be careful here that you do not try and say cancel or say reduce this y against one of the y's down here. You cannot simplify or reduce within polynomials. Okay, so this is a binomial. Oops. That's not what I want to do. This is a binomial. This is a binomial. You cannot cancel individual terms within the binomial. Okay, you can only cancel or reduce factors if you're looking at a multiplication, so or division. So what we're going to do here is we're actually going to factor this. So over here in this numerator, there's a greatest common factor of 6. We can factor out a 6, which means we're left with y minus 5. The denominator stays the same, times. In this numerator, we can factor out a 5, which leaves us with y minus 1. And in this denominator here, the greatest common factor is going to be 3y, which leaves us with y minus 5. And now we can see that this binomial here can cancel against this binomial here. So you can cancel one polynomial against the entire polynomial. We're not picking out individual terms. It's the entire binomial here being cancelled against this one. We can do that because it's being multiplied by up here by 6 and down here by 3y. These are products, which means we can cancel them. So this one will cancel this one. And the y minus 1 will cancel y minus 1. And we can divide the 3 by 3, so that disappears, and then divide the 6 by 3, which gives us 2. And that's about it. Let's just write out what we have left. In the numerator, we have a 2 and a 5 times 5. And in the denominator, the only thing that's left is a y. So we can just multiply the numerator. That's going to be 10 over y, where the y cannot equal to 0. Y cannot equal to 0. But now as we go back, we also see that y cannot equal to positive 5, because 5 minus 5 is 0. Y can also not equal to positive 1, because 1 minus 1 is 0. So we actually have three non-permissible values. We have y cannot equal to 0, y cannot equal to 1, and y cannot equal to 5. Okay?